Yeah.
So the next speaker is Manon Besset. I hope I pronounce it correctly. From IC France, and Manon will talk about towards a combined global, comparative, multi-criteria, and multidisciplinary approach to better assess the vulnerability of Mediterranean deltas. Please, Manon.
I will focus on demonstrating my scientific approach to assess the vulnerability of river deltas, especially in the Mediterranean and Black Seas, without developing in detail one of my published works. So I hope this will be well received from you, and the goal is to share my vision of current coastal geomorphology. To start, a delta is a part of a vast geomorphological system at the land-sea continuum. It is initially built by a river, mainly supplying water from precipitation drained to the lake, the sea, or the ocean, and sediments by mechanical erosion, mainly from the watershed. The delta is composed of a delta plain and another subaqueous part, separated from the first by the coastline. The delta is a lowland with mobile sediment, and the river is the main contributor in the deltaic development, but marine forcing such as waves, tides, and nearshore induced currents also play a significant role in remodeling in sediment distribution offshore and along adjacent coasts, even in the Mouth Channel. So the river delta shelters more than 500 million people on Earth and constitutes an ecosystemic, economic, and social cultural richness. For this environmental and human issues, the deltas are increasingly occupied and exploited, in particular deprived of sediments trapped behind dams. Many deltas around the world are becoming increasingly vulnerable to the accelerated subsidence and the increased coastal erosion, which are traditionally the two manifestations of the deltaic vulnerability. These deltas then lose large areas, and they are more vulnerable to marine submersion and the river flooding and the sea level rise. The increasing vulnerability has significant political, economic, and environmental consequences for many deltas around the world, and calls for coordinated international efforts to maintain or restore the sustainability of these deltas are beginning to gain importance. The deltas of the Mediterranean coasts and Black Sea coasts also are not spared either. The age of our civilization is also the cause of a deep and lasting imprint on these Mediterranean deltas. And for example, here you can see the irrigation canal and agricultural areas covering almost the entire Ebro Delta in Spain from this simple Spot 5 satellite image. You can also observe the position and the river water storage capacity of the deltas, the dams, sorry, along the river of the major deltas. You can also observe the incredible population density in the Nile Delta in Egypt, averaging 1,500 people per square kilometers. These coastal areas are massively coveted and yet already naturally so fragile. The slope is very low, as I said already, and the deltaic plain is very close to sea level, which makes them widely exposed to river flooding and marine submersion. My theme is rather wide because I try to assess different issues on deltas in order to better define what makes them vulnerable and how they are. And for this, we need to better understand their natural dynamics, to know their past evolution, to identify their pressures, and to monitor, of course. And this is not possible without working at large scales, covering the system from source to sink, and collaborating with scientific experts of various disciplines. Since the start of my presentation, I have been using global databases, literature, and information that we extract from satellite imageries. The satellite archives allow to monitor deltas with global and long-term coverages, high time frequencies as well, and their possibilities are in constant evolution. The second main step of my scientific strategy is to compare deltas using standardized criteria from physical forcing acting on the delta evolution and from external constraints such as human activities. When you compare deltas, you must keep in mind that they all have specificities, and consulting the local experts is important. The third part of my approach is the delta classification. Each classification may vary because we use different criteria. The goal would be to materialize all the existing classification for feeding a big one that can exactly explain the delta vulnerability. We have works for that. Okay, so to better understand the data's disciplinary and temporal crossover strategy must be considered, and for that we need experts in different topics. To go as far as possible in the understanding of the deltas, it is also fundamental to exploit all that already exists in terms of data and knowledges, and to apply the crossing of these topics with these timescales. If I summarize the main recent works I conducted, we can group them in 5 different topics, which are human impacts of the delta dynamics, impacts of extreme hazards, effects such as hurricanes, for instance, effects of climate change, classification of deltas regarding their natural and forced dynamics, and long-term evolution. I was lucky to work with eminent specialists of various disciplines, and I even worked for 2 years with a physicist and mathematician to convert my delta sites into formulas, but it's another story. This multidisciplinary effort continues as I joined an international team to draw a 7,000-year panorama of human influence on deltas. Concerning the Mediterranean and Black Sea coasts, I conducted researches on several deltas, and in this presentation, I will focus on those that are in red on the map. So here you have a map where are located the river deltas that I'm used to study. And among them, there are several Mediterranean ones. Even if they are in the same region, these deltas evolve through different climate conditions, but not only. Their size is also very different. So we have to deal with a wide range of deltaic areas, which are particularly controlled by various river sedimentary regions. This map shows to the global sediment load for the rivers, and we see a strong variability of the sediment loads between the different sites by a factor of 10 for the Mediterranean and Black Sea sites. Marine systems are different from one site to another as well. Generally, the lowest significant wave heights are in closed and semi-enclosed areas, such as the Mediterranean Sea and the Gulf of Mexico. But inside the Mediterranean basin and Black Sea coast, we can also observe heterogeneous marine conditions, so different exposures to marine hazards. The tidal range also varies, but for Mediterranean and Black Sea deltas, this variation is not so important between these deltas. So as you can see, river deltas are extremely complex and varied natural ecosystems and even unique environments. Even their global shape is different. Here you have 9 examples of major deltas in Mediterranean coasts. So to define the delta vulnerability, the shoreline change is one of the main indicators, relatively easy to analyze using satellite imagery. And in this slide, you can see 10 Mediterranean and Black Sea deltas and their coastal area evolution since the 70s. And for some of them, the coastal erosion with land loss in red is visually obvious. The long-term trend analysis is not sufficient to define the coastal dynamics of these deltas. The short-term evolution is also important and can reveal some seasonal or temporal weaknesses or some hotspots of erosion. So recently, with my super team at High Sea, a society managed by 2 women, indeed, we developed algorithms and tools for automatically extract shorelines and bathymetries at high time frequency. Here is an example annually, but we have more frequent. And this example is the Rhône Delta in France. Land use and changes can also be mapped using satellite imageries to highlight overused deltas, but also overexposed population. Here you have an example for the Nile Delta with its very artificial land use. I also quickly present you one of the classifications we built with an intern for comparing 5 deltas in Mediterranean and Black Seas. We used different global databases and models. We selected several variables for defining the levels of occurrence of extreme hazards, the levels of exposure for deltas and populations, and the levels of delta resiliency. The combination of these criteria provide one of the vulnerability classification of these deltas compared together. So after analyzing the recent delta evolution, classifying the sites in terms of current delta vulnerability, we tried to define the effects of projected climate changes, such as sea level rise or change in runoff on the delta dynamics. This approach is new and experimental, totally based on hydrodynamics. So this is the last picture on the right side. I am sorry to not have enough time for explaining this classification, ternary classification. But inside you have you have a rows that show the change, the future change in a few decades of the natural dynamics of deltas due to pressures on the climate change. Next step is to integrate the morphological classification and the sedimentary specificities of these deltas in this classification. So to conclude, satellite imagery is so important for this approach for monitoring deltas at the system scale. Crossing disciplines and collaborations are also important. We need to cross time and spatial scales, and to mutualize, to centralize the databases for comparison. But I want to highlight a point I did not presented, if the complementary between this approach, this global approach, with the very local and very accurate approach through in situ data, field campaign, as the field expertise is very important to gain in perspective and gain in interpretation. Thank you very much.
Thank you very much for your talk, for a very interesting and inspiring talk. We have some questions I see in the chat. Question from, it's a question from
It's Mios.
Thank you, Nikki. Can you please?
Yeah. Okay. So this approach is suitable for fan deltas smaller in size. It can be. We tried to study the small deltas. Actually, in my database of deltas, we have very small ones, and we are we start work with a Spanish team for working on gravel bed deltas that are smaller than those I show you today. And just a question is, what is the resolution of the satellite imageries? And you can use very high resolution satellite imageries, but it takes time to have that, and the time series is shorter, obviously. So yeah, we can work with very small areas with 50 centimeters resolution. With yeah, it's crazy. It's just an adaptation of the method, but yeah, it's possible. You're welcome.
Okay, thank you. Other questions, please? Did you say something? Okay, so if there is no other question, then I think we can take a break now, and we are going to be back. At your time, it's going to be 15 and 10, and so it's like 40 minutes break now. So we'll see you all in 10 past 15.
Thank you very much.
Thank you very much.